Hello guys, welcome back to Techdose, and in this video we are going to look at a live session from the course AI for SDE. Here we will be learning all about hallucinations and agentic RAG. In hallucinations we will try to learn what is hallucination, how does it happen, is it luck driven, and the maths behind the hallucination, and finally we will look at how to mitigate hallucinations. Then we will come to the topic of agentic RAG, where we will first be seeing the RAG pipeline architecture, then the retriever, re-ranker, and the generator, and then we will look at the terms agents, agentic AI, and all those things, and how LLMs, vector DB, and agents are actually interacting. Are they same or are they different? And where do they stand with respect to this agentic RAG architecture? Agentic RAG is also not something with 100% correctness. So we will be looking at the failure scenarios for agentic RAG, and the standard RAG will be compared with the agentic RAG to understand how agentic RAG is different from the naive RAG. Before starting this session, I would like to tell you that this is one of the live session from the AI for SDE course, which is running for 6 months. It is a live training program and it is going to start soon. So you can just contact us on WhatsApp or visit our website techdose.co.in. Please watch this session from the beginning till the end to get into all the technical details of this live session. Let's get started. This session is going to have many parts. As you know, from the poster itself, what we are going to discuss, we are going to start by understanding about why you should care about learning this thing, right? Because maybe that's the most important question that comes to mind, that okay, many things are there to study, but why should I care about learning this particular thing at this particular time? Then we will be seeing the technical terms. Once we go through the first topic of why we are here, then we will be starting with the technical things. And the first technical thing that we are going to start with is hallucination, and then how to get rid of hallucination, what the industry is currently using to get rid of it, and what most of the teams are actually using it, and how the entire pipeline works end to end, and what is the problem with that pipeline, and what work is still ongoing, so that you actually know the trade-offs of what you are getting into and what you are using, right? Not just try to use something because it has got a hype behind it, isn't it? So that's what we are here to learn about, right? So let's start with the first point of why you should try to learn what we are going to do or anything related stuff. So currently, there is a lot of hype about AI agents, and you can say that some of it is kind of not too much sensible, and a lot of it is sensible at the same time, because it is not like people are not using it. It is getting used. And the second thing is rushing on to using the agents, that let me do some hands-on the agents so that I will become more relevant. So it's just a matter of time that you will become irrelevant in that. It is just like you rushing to use some kind of API on some kind of data structures and not knowing how it works. So it just in the beginning you might find some relevance, but as soon as people catch up to that, as soon as people learn those things, you will immediately become irrelevant. That's point number one, right? You want to not just sound cool, but you should be sounding more grounded, and as if this is like a natural thing that comes to you. It should not be like something you are saying to sound cool. It is just like can you have a technical conversation regarding the topic without having to force yourself to use the terms? That's the main goal of what you are trying to do, right? Second thing is, are you just caring about using the I mean, using some end mile stuff, that something is built already and trying to integrate something? Or do you understand the trade-offs of using something in your application, right? So when you are giving any kind of design round or any kind of senior level staff engineer level interview, currently in the current standard, nobody wants to know about what is this. People want to know about the trade-offs of something that you are going to use. People want to know all the details that you can give them, and how the future can get affected because of the decisions that you make right now. You can't just say that okay, this is the thing that will solve such problem and that's it. You can't get get around the interview with that. Okay. Definitely, you can expect that even more experienced people will be taking your interview. So if those guys who are just speaking something versus those who actually know can be separated, can be segregated easily. Okay, so we cannot get out of these things. Third thing, if you are already into some startup or in some startup culture, or you are owning something that is transforming your team, maybe you are an SDET and you are already integrating agents into your workflow to make use of the AI workflow in the testing field. In that case, somebody like you can take the responsibility of this transformation step. But this responsibility, you get very less time to implement something in office, isn't it? And you just see like how to get this job done by reading less. But that is not how these things are going to work out. You have to spend more time in reading, more time in how it works, and less time in how to implement it, because you will know how to add something or attach something to something, right? And make it work. If you can understand what I'm meaning to say. So in this particular case, it is not about just building an agentic workflow, but this is also about how you will fine tune, how you will design, and how you will integrate everything together to make a workflow. Like what all happens before you try to build an agent, right? And what are the part of the agent? What is the brain of the agent? What are the different services that the agent may use? Not just to make a certain agent, right? So that is the goal of this entire thing, that why you should care about studying this, because the relevance of this is going to be higher in future. That future can be just six months ahead of you. That future can just be 4 months ahead of you, or it can be the next year. I am not saying about the speed of when you are going to see this thing, but you will be seeing this already. It has been added in the interview as one of the rounds. If you are not aware, then I'm telling you that one of the rounds have been added already, starting from SD1. SD1 is also having this round. Okay, in Amazon, they have started asking this. I had shared you already in the group, and senior levels, definitely this is there, right? So I hope we are clear. We must know the fundamentals. This is more about the software engineers. This will not transition you to being a machine learning engineer. While a machine learning engineer is more specialized role, you may require multiple years of training, 3 to 4 years of training to become a machine learning engineer, or to start even to say that you can do machine learning job. This is more about being a software engineer. What should you know from your side to make the better use of engineering, and how you can actually contribute to engineering in this using the AI workflows. It's not about that this course is going to transform you to some machine learning engineer. So that is not a correct expectation, right? If you are thinking like that, yeah, there are many more things to study, not just this. So I think we should get started with the technical things. And this is just a master class from one of the session that we are going to have, particularly in the fourth or fifth class, maybe in May. So those of you who have already enrolled, you will see this again coming. And this is just a part of a class. Generally, the class is around 2 to 3 hours long, which is at the exact same time, 10 to 1 or 10 to 12. And you will see this is a part taken from that class. Some of the prerequisites I will always clear, but if you have already attended my vector DB classes in the back, then you will find more at ease, right? If you know about vector embeddings and how vector DB works, all those things. If you don't know anything, you can just treat it like a black box and continue. Okay. So let's get started, and I will be asking you questions as well, so that to understand what is the high level understanding that you have, you can give your understanding on the matter. Let's start with the hallucination. Okay, that is our first topic. Hallucination. Okay. So if someone can give me what do you understand by hallucination? If you can just try to give an answer for this. What do you understand by hallucination?
When the AI agent which we are using starts giving incorrect answers.
Okay, let's remove that term AI agent and let's just think in normal terms. Let's think in the GPT terms, right? Because everyone has used GPT. In the GPT, if you ask something, when do you say it is hallucinating? When it is giving wrong answer, as you said, right? So wrong answer, I mean, I will not relate wrong answer to this because maybe my expectation is something and the query that I have made is a little vague. So that the answer that is predicted does not suit me, but someone else wishing to get the same answer would have written the query in the similar way. So hallucination is exactly defined as when all the resources are present with you. All the resources are present. Correct answer could have been derived. The query is also clear. Then if the engine is giving you some kind of answer that is unexpected, then we will say that it is hallucinating. Because what may happen is the information set is maybe not containing the answer itself or containing it in a very vague fashion. Then if the information or knowledge is not available with the engine, you cannot expect correct answer with that. But that is not something which is hallucinating, even if you don't get correct answer. What I'm expecting as hallucinating is I told you, I know that you have this information, but still you are giving me an expected answer for the clear set of queries that I have written. That is hallucination, right? So yes, it can be considered as wrong answer, but wrong answer is like a larger set of outputs. In that, hallucinating output is something where you should have given me the correct answer. There is no way that you cannot give me the correct answer, right? That's what I'm thinking about it. Before talking in detail about what is hallucination and why it happens and how to avoid it, let's think about something called as the autoregressive models. Autoregressive models, because this is the model that we are using nowadays. The autoregressive models is when you have, in simple terms, when you have written some words like I am the dash. After this, when you have typed I am the, after that, what the model will try to predict the next word prediction. When your model does next word prediction, those models are autoregressive models. That means it knows about the past of what you have typed and it needs to predict your next word. GPT is an autoregressive model, right? You write something, it tries to make sense of what can be the next word using the previous knowledge in this context memory. It has memory in place. It will remember what all things you have written and it will try to predict what you are trying to write and it will try to make sense of everything together, right? Those models are autoregressive. You should also be clear that all the LLMs are not autoregressive. All the large language models are not autoregressive. GPT is autoregressive, whereas the BERT model is not autoregressive. This is also a large language model, but not autoregressive. BERT can look at all the left and right side to find out the masked word. That if you have written IMD and you have written something on the right side, it can look at the both side and fill in the blank. Whereas the autoregressive model like the GPT will only look on the left side and fill this up. So which one will have more context in filling up the masked value? BERT will give you higher performance there. So that has a special use case. BERT can unmask a certain masked value with much higher accuracy, with more context than GPT, because GPT just works one side, left to right, whereas BERT works in the bidirectional way. It can look on both the side and it can predict. But think about it. If you are typing something left to right, BERT has no extra benefit over GPT. Whereas GPT, which is specialized on this job, next word prediction, will perform better in such scenarios, right? So we are in this case, we are trying to focus on only the autoregressive models where we are moving from left to right, typing each thing, each and everything, right? That's what we are trying to do. Okay, I think we are clear with this. Now let's say if I'm saying that, okay, will GPT remember everything from the past? It will not remember everything from the past because it has its own memory limitations. You cannot give a lot of input and hope that it will remember everything. That will come into the pro version of having more memory. If you want to allocate more memory, you have to pay more money for it, right? Isn't it? So you can assume something like what will be the context memory? The context memory will be a sliding window of a fixed size where you type the next word, this comes under the sliding window if something is removed from the left side. You type the next word, it comes into the sliding window of context memory. Something is lost from the left side. If you have used GPT extensively, you will know that something from some timeline, if you go back in some time, then it will not be remembering the things. If you ask it, it will not remember. Depending on what pro version you are using, it will try to remember more and more points, right? So that is what is happening with the context memory. Let's say that it can remember 10 words in the past. For just simplicity, I'm saying just 10 words in the past. Then any context which is outside of 10 word will not be so much, it will not be making so much sense to predict the next word, even if it is related. So think about it. If you have a pro version which can remember 100 words in the past versus if you have a free version which remembers 10 words in the past, even if you use the same model, you will get better answer with 100 words remembering, right? Simply, even with the same model. So it's not like just the model is improving. It is it is like your memory, your how much you can remember in the past that will help you give better answer in future even with the same model. So there are many factors to something which removes your hallucination or something which can produce better answer to a given query or a given context, right? Okay. Now let's take a simple example to understand this. Let's say that the current president of US is, and then we are trying to predict what should be the next word. The current president of US is which person? We are trying to write a word there. Let's say that in our setup, Joe has 60% and let's say Donald has 30% chance. Chances could be anything. Okay, it is based on your knowledge base. What is the chance? It could have been in the other way around. It can be any other percentage. Other names are also given like Ronald or something, which adds up to make 100%, but I'm just focusing on the top two percentage that is given. Based on this percentage and based on, let's say, some kind of greedy selection, the highest percentage is taken into account and you have written Joe here. Then if you want to predict the next word, then if I give you two options, like let's say Biden and I give you Trump, you will find that Biden will have very high chance of getting predicted as the next word, whereas Trump may have very less percentage chance because there is no name called Joe Trump or something, right? That is present in the database. So in that sense, if you want to do next word prediction, having predicted this word as wrong word, let's say that somehow you cannot expect everything to work with 100% efficiency. Let's say you predicted something which is not true. The chance it produces as the next word getting what should be the, will you choose the correct path or will you choose the wrong path, it will exponentially increase in each of the chances whenever you make the choice. If you had chosen here, let's say Donald, the first option would have been Donald, then Trump as the next word option may have been 95%, and maybe something like Biden may have 1 or 2% chance depending on what you would have selected in the past, what you had selected in the past, isn't it? Why hallucination happens even? Because one wrong choice and then you try to justify that wrong choice. Once you lie somewhere, you want to justify that lie, you keep on making a bridge of lies, and that becomes very difficult to keep it stable, right? If you keep lying, you can't just lie one time and then correct your answer. Once the model chooses Joe, then this goes into the context memory. If it goes into the context, then the next word will be predicted only based on the context. So, this is exponential growth of deviation. If this is the correct path that you should take, once you deviate from it, then you will deviate further away. It will be an exponential deviation from there because now you are willing to justify your last option. Now, since I said that it is a sliding window of words, even if you go to the next word, it is the wrong words only that you are remembering all the time, right? So more and more wrong words, one wrong word will lead to a very high chance of the next wrong word. Two wrong words will lead to even more exponentially growing higher chance of the next wrong word. This is called a snowball effect. In general term, it is called snowball effect. That once the snowball starts rolling from a hill, it is small. It has a lower surface area. As it grows, the growth rate will increase, isn't it? The growth rate will increase. So the larger the snowball, the larger will be the growth rate. And this is the same. It is the same. And can we expect that sometimes it can get wrong? Yes. We will try to understand with some 4 or 5 techniques of what is the technique of actually selecting the next word. I didn't tell you anything technical here, but let's say we agree that 100% of the time things may not be correct. Because if you are thinking that, okay, why did we have 60% chance here? Maybe it is based on the database that you have trained on. The chance will be calculated based on the database which was used in the training. Can you always make sure that your training data set will always have everything correct and will always produce some distribution which will be absolutely correct for each of the word? That cannot be guaranteed. That cannot be guaranteed, right? So because of that, the chances cannot be the same for each of them. It cannot be always correctly distributed. That is one thing. The second thing is, maybe I don't want to make my LLM look robotic so that it always picks the highest percentage and always the same answer is coming. If the question is re-asked, then maybe I would want to be creative. I want to induce some creativity into my LLM, into my language model. At that point, at that point, I cannot just choose the highest percentage and say that this is the only answer that I will have all the time. Then wouldn't it be very robotic? Then where is the human sense there? If I ask you the same question 2 times, you will feel like I should explain it in a different way, isn't it? You will not answer the exact same thing word for word after that, right? So, because of that, there are different techniques that don't just do greedy selection based on the top percentage. Even though that do not guarantee correct answer every time, still I will willingly not want the highest percentage all the time. Maybe the user is not articulative enough to ask the exact thing that it wants. Then in that case, the percentage distribution chance that is coming with the prediction as per the query is not accurate because the query itself was not accurate. Then what to do? Then how can you depend on the percentage distribution all the time? Isn't it? So there are many issues, and in industry, the percentage distribution with the greedy is not taken into consideration. This is not the technique that they are following. Okay, but this is the simplest one to understand right in the beginning. So I gave you. So have you understood how this hallucination gets created? It gets created due to the probability of all the seen words. So let's say that you have seen many words in your context from word xi plus 1 and so on till xt minus 1. Everything is in context and you want to predict what is this word xt. Then the probability of xt will depend on the probability of all the past seen words from xi plus 1 and so on till xt minus 1. Okay, what were put in that context will decide what will be xt, isn't it? So you make more wrong choices in the past, you made more wrong choices, you will try to justify that wrong choice by making a wrong choice again. So you cannot correct it. If your query ends, you have to instruct that maybe this is something that needs self-evaluation or re-evaluation. Then maybe it may correct, because then it will try to lose the context memory and try to rederive or be skeptical on your entire answer. But if you don't put some kind of ruling, then it will continue on its merry path, right? Okay, this is the thing that industry do not want, because when you are doing something internal, you can't go elsewhere, you can't use public APIs to actually, confirm what is happening in your company's work. You can't share the data. And that is where some grounding truth have to be present. Something has to be present with which you match and find out that, okay, I am not just answering something, but these are the references from which I have taken these answers. That's it. That is where the RAG comes into picture. That means the retrieval augmented generation. That means you don't just generate the answer, but attach each of the chunk of the answer with some backup. That means something from the database. Since this is present in the database at this and this entry, you can follow this reference to read more, like how Wikipedia writes something. If Wikipedia writes something, it is not just an overview. It is always having so many references to it, right? It is not writing whatever it wants to write. You can see perplexity search. When you search there, they will be giving you search result with references. You don't find that any random stuff will not be written, right? Everything will have some kind of backup. Okay. Now let's see some of the techniques of what people are actually using. If this is not the technique, then maybe what is the technique? This is called your greedy search technique, right? As it makes sense. Greedy search. Greedy search is always pick the best option that is there as per the query. As per the query or whatever you are writing, that can do the next word prediction based on it. Greedy search. Always pick the highest percentage. But it can be repetitive and it can be robotic. It lacks creativity. There is no creativity to this. Okay, so people want more creativity. So what to do? One another technique that is used is called random sampling. Random sampling. Let me give you an example, a running example, so as to make you understand. Let's say an example is present, the tiger was, and you have to fill the next word. Let's say the chance that I'm getting running is 30%. Hiding, tiger was hiding, 20%. Then I say relaxing is 10%. Then I say chasing option is 5%. Then I say hungry is, let's say, 25%. Then I say frightened is, let's say, 2%. Then I say killed, tiger was killed, 1%. Then I say sleeping is, let's say, 7%. I hope it adds up to 100%. If it not, then my intention is that it adds up to 100%. Let's say these are all the options that are present for the next word selection. What the greedy search will return? Can you give me that answer? What the greedy search will return as the next word?
Running.
Yeah, running, because
Tick,
it has the
tick.
highest percentage, right? It will always return run. How do you know it was running only? I mean, why can't it be something else? Just because the chance is less means it cannot be anything else. That is not true, right? That is not true. So greedy search is lacking creativity. Running can be one possible answer, but not the only possible answer. Then we are doing random sampling. What random sampling does is it will try to it will try to roll a die, and it will try to create these many faces in the die, these many dimensions in the die. So that if I say that simply 1 to 30 will go to running. If I have a die with 100 number, 1 to 100, if I roll the die, if I get anything from 1 to 30, I will put running there. If I get anything from 31 to 50, I'm going to put hiding there. Okay, I think you have understood this. You will have the range assigned to each of the words based on the percentages. And after that, if you generate a random number from 1 to 100, that's what I'm trying to do by saying rolling a die. Whatever you get, that one you will predict as the answer. That is random sampling. In the random sampling, there will be a lot of creativity, because one time you get 25, next time you can get something like 49, which is, then it will try to say hiding. Next time you write, it will predict something else, right? So you have creativity, you have diversity, definitely. With the creativity, you have diversity in the answer. You don't sound robotic. You sound more human-like. Because if I ask you the same question, this fill in the blank again and again, you will try to give me different answers, right? You don't want to just predict the same point and say this is the only answer. You don't want to say that, right? So maybe in certain cases, I would have gone for greedy search, but maybe to make it more human-like, I will go with random sampling. Seems better, right? Seems better. But the problem in random sampling is we have too many choices, and maybe some choices are something that is too odd. Sometimes it will have 1% chance of getting killed as well. But maybe this is something that I don't want to predict because the quality of this answer will not be very good. So I want to remove some portion of it and only take someone with some good percentage figure and try to roll die only for those guys. Don't want to roll die for everyone. Can we not do like that? Yes, we can do like that. Let's say that you had selected only top three. I mean, let's say top two. For easier calculation, I'll just give you top two. For top two, you had selected. I will take the top two greedily and try to apply random sampling on top of this, isn't it? Then how you will apply? You take the top two, you find out what is the total percentage you are getting. 50% is the total that you are getting. You have to do a normalization on that. How do you do normalization? You take the percentage. You convert this 50 as if it is 100. Then how much it will scale? It will scale to 60% and this will scale to 40%, right? Isn't it? How do you scale? You take the current percentage by total percentage into 100. That's how you scale it. So you scale, you will get 60, and for this you will get 40. If you had more numbers, like if I had taken top three, then your total percentage would have been 60%. Then if you want to scale this up, then it will be 30 by total percentage 60 into 100. So this will give you 50% weightage, right? Instead of 60, it will give you 50% weightage. That's how you do normalization of the figure. This will give you 50%, right? How much this will give you? 20 by 60 into 100. I think 33.33. 33.33%. And the rest percentage will go to 10%, which is 1/6 of your 100. How much is that? This is 83. So this will be 16.67%, right? 16.67, 33.33%, and this is 50%. Now you roll a die based on this. This is even better because you are removing low quality answers. You applied logic to remove low quality answer because you know these are not something that I'm interested in. In the high quality answers that you found out, top K answers, top K, filtered out top K and then applying random sampling on that, isn't it? That is called top K sampling. This is also one good technique. Top K sampling. You take top K. Okay, but you know what? This top K is a fixed number that you have to give, may not be very good. If I say top three, maybe one is 60%, one is 39%, and one is only 1%. Then what's the point of getting top three when one of them is also not a very good choice, isn't it? Right? Top K does not guarantee that all the K will be good quality answers. In this example, it just came out to be maybe good quality answer. But you see the other example, 60, 39, 1%. Or maybe 60, 39, 0.1%, 0.1%, 0.05%, and so on will come. So top three will have the 0.1% as well. So this is not a good idea. Maybe it is a seemingly better idea than random sampling, but it's not something like which is going to be very revolutionary. It is having its own set of problem because of the fixed K value that you have to give. So people came out with another optimization on this. And what they said is, let's have a certain bound of what I define as the best quality. Okay, let's say that one improvement was I will take everything above 40% as the good quality answers, and I will filter out everything above 40%, and then I will give it to the system, and it will try to do rolling die on that. Have you understood? So maybe there are two answers which are above 40%. But the problem in this technique was maybe there is nobody who is above 40%. You look at our example, nobody above 40%. Even if I had put, okay, then I will take everything above 30%. Here, there is only one option above 30%. Then you will say that, no, no, I will take everything above 10%. You may not have anything above 10%. You may have hundreds of options which add up to 100%, but no one is 10% and above. Then what? And if you reduce the number too much, like let's say I will say everything above 1%, maybe you have 100 choices suddenly, everyone having 1%. Then what? This was a thought process which went beyond this top case sampling, but it was also rejected and it was improved even beyond this point, saying that let's not have a fixed percentage figure. But what I can say is from the best option, I will try to take a standard deviation. Like let's take whatever is the best percentage. Let's say the best percentage is max M. I will take anything which is 30% and more in the bracket, in the good bracket. Like if let's say the max here is 30%, right? When I say that some value 0.3, I want to take anything which is above this 9% mark, which is a multiplier. I'm giving a multiplier that whatever is my best option, M is my best option. I will take all the percentages which is better than M times, let's call it P, M times P. Whichever one is better than MP, I will try to take them. Let's say that the P value here is 0.3. Then if my max value here is 30%, then I will take anything greater than equals to 9%. Then you will filter out all those options which are greater than 9%. Then in this case, you are not providing a hard bound on something, but you are taking a deviation that I'm taking 70% bracket margin from the max word. The max word, if it is higher 70%, then I will take everyone who is above greater than equals to 21%, isn't it? Right? So this margin is also now variable depending on what is the percentage of your best word selection, isn't it? So this is called top P. This is what the industry is using now. Top P. Top P is getting used in the industry because this is first of all variable. This has nothing to do with, something exactly having giving a fixed number, and you can't get cases where you do not have any word also, isn't it? You can't get such cases. And you maintain decent quality as well because of the gap margin that you have given, isn't it? So maybe the maximum only has 1% chance, but in the gap margin, only those things will be taken. Hope you guys are understanding. So in this case, what was more robotic and less human-like? It was the greedy search. Then we kept on improving our result more and more. Random sampling seemed better than the greedy search. The tops K seemed even better than that. But the top P is the one that is getting rid of the problems of the top K. We know what was the problem of the top K, right? Yes.
So if the recent words have so much influence on the next prediction, then won't even slight deviation, like let's say I'm choosing the second or third best option, that will keep exponentially decreasing the quality of the answer that the LLM is producing?
It will always do. If you choose a wrong answer, then it will always create such kind of problem. But now we are trying to understand how the hallucination is happening. So
Okay.
which technique is used? It is not avoiding technique. These techniques are used and this will generate the next word, and then you will understand that how the next word prediction is done. Then you will know why hallucination is happening, right? So
Hmm.
this is just about next word prediction. So
Okay.
let's call I mean the minimum barrier, let's call it the min p. Instead of top p, let's call it min p. Okay, min p is a baseline that is given, and above that only we are fixing all the values. Okay, let's call it min p. This is the industrial standard that is getting taken. But after that came another good strategy. After that came another good strategy, which just says that if I want diversity in my answer, then maybe I will take enough point that adds up to, let's say, something like 90%. Just take enough answer, remove that min p and everything. Want to simplify everything. Take take the points in the sorted order, not just randomly, sorted order. Keep adding up until we reach to 90%. 30 plus 20, 50 plus 10. I mean, it is not sorted, right? 30 plus 25 will come, which is 55. Then you have 75, 85, and then you have 92. So only select these words: sleeping, hungry, relaxing, hiding, and running, which adds up. As soon as it adds up to 90% and more, you stop and then you do rolling die there. Okay. Then we have another industry standard top P. So there is a difference between top P and min P. So this is again a top P. So people try to choose one of these things if you want more diversity in your answer, but don't want to let out good quality answers, you can go with the 90% selection. The min P, however, has another issue that says that if you select min P value, I mean the P value too high, let's say 0.5, and if your best quality answer is, let's say 50%, then the zero point 0.5 will make sure that everything above 25% must be selected 50 times 0.5. Maybe the next best word is below 25%. Then you will just end up in a more robotic fashion, right? Isn't it? And the top P, however, says that if you add up to 90%, even if there is one word, if it has high enough chance, then let me be robotic. If it is 90% chance, then let me be robotic. But if many words are there which adds up to 90%, then those should be the selection process. So these two are the ones that is under the scanner, and these two are the ones that are getting used. Most people want diversity, they go with top P. Most people want some control, so they go with the min P as well. Okay, I think the
Is that
evolution is yeah, clear, right?
is that 90% threshold? Is that fixed
It
number?
may not be fixed. It can be like you want to go with some other number, like how the training in the training process as well, iterations are not fixed. You can go with any number of iterations, any number of points, but generally we go with 90%.
What if we have like two options with a very high percentage of number, everything else is like 1%, half a percent, things like
Yeah,
that.
then
Let's say,
then that's what I said, that if you have high percentage chance for somebody, then maybe let me be robotic. If there is nobody with high percentage, let's say everyone is 1%, 2%, then you will keep on adding at least 90 options like that, 90 to 100 options until you add up. So this is a prefix number added, right? Until you add up to 90%, until you reach that mark, everything will come into your option set, isn't it?
yeah.
Right. So now you know how the next word selection is done in a certain line, like the tiger was something. Generally, this is not the direct technique. We don't just take this word for word and do the next word selection, but rather we build a vocabulary. The vocabulary is done by a byte pair encoder, that is a BPE, that is a separate thing, that will convert each of these into token IDs, and each of the IDs will be present, and based on IDs it tries to predict. So there is no, it is not generally done on an English word or something. It is generally based on the ASCII values, that the ASCII values will be replacing the characters. Maybe the vocabulary set will be a map where each of the unique word has its own ID. Then you convert each of them into some kind of vector, and that is how the things work. But we are trying to understand at a high level because we have not done such kind of things, which is prerequisite of this entire thing. The prerequisite of this would be to understand about embeddings, how those are created. Prerequisite is also encoders, and to code it as well. If you have written your own encoder and decoder, then that will provide more clarity on these things, right? But we are trying to understand in English term. Okay. So in English term, what we have understood till now, how the next word prediction can happen. We have seen five of the techniques, and we have seen all the drawbacks and how each of the techniques is trying to improve on this drawback, but in turn creates its own drawback, and which are the industrial standard. And and after this, you can now relate it back to what we said, or what we studied in the last page, like the next word prediction will lead to further errors, and it will lead to exponential growth of errors as soon as you create your first error, right? As soon as you create your first error. So we don't want to get into some kind of trouble, right? Okay, we don't want to get into such kind of trouble. We want to be more specific to our answers, because if there is chance of hallucination, how can I reduce that chance? How can I be correct? There can be two things: whether you improve on prompt engineering, whether you improve on flow engineering. So there are two things that are there: prompt engineering and flow engineering here. The prompt engineering says that you write better queries, you write refined queries, you give context, you don't do a Q&A. Zero shot means you are just asking the question. One shot means you have given an example and then you are asking something similar. Few shot means you have given many examples and then you are asking the question. Right? So then you can ask GPT how I mean, are you zero shot, one shot, few shot, what you are? GPT will answer that I can do zero shot as well. You can try that out right now. Okay. It will say that yeah, I am zero shot, or maybe it will answer in a roundabout way, but it will also mean that it can do zero shot answering. But the chance of hallucination in a zero shot answering is pretty high. You can just check it right now. Are you zero shot, one shot, few shot, what you are? Okay. Whatever it answers, it will definitely be zero shot as well. Okay. But the chance of hallucination reduces as when you give more questions and answer, question and answer. Okay. So if you are few shot, if you are a zero shot model, but you are querying based on a few shot, that means you have given some samples that this is how, if I ask this, then this is the answer. Then it reduces the chance of selecting some bad option by the LLM. Whereas if you just ask randomly that tell me some best phones which I can buy, it will not do such a good job. Maybe if you tell about some history of the things that you have bought, it can get an idea of your budget, maybe an idea of your lifestyle, maybe what you own prior to something, and then it can recommend you better. So what is a wrong answer here? I cannot say anything is wrong answer, but it can give you an improved result in such cases, right? Isn't it? It can give you improved result. Now there is always a country bias into this thing. You should always take into account the country bias. Whenever you are using Chat GPT, it will try to promote US or things which are related to US product. If you use DeepSeek, it will try to promote more Chinese products or something which is not US based. And that's why these things are not included as a part of selection process, but this can also lead to some kind of hallucination because of their own system bias. It is not that you wrote some different query. You ask about the top 5 super bikes that I can buy. The recommendation that you get from GPT will not be the same as you get on DeepSeek and in Claude. Will be different. But which answer is a better answer? Everyone has their own bias. Where you are inclined to, you will find that answer better. Maybe if you want to make it a few short, that you are in this country, that country, you like this thing, that thing, and then you ask what recommend me top 5 bikes, it will recommend different answers. So few short is always better. And prompt engineering says how to manufacture your prompt. Okay. Then you have flow engineering. This is what you should focus on as a software engineer. Flow engineering says that whatever is the prompt, I want to produce the best answer on my backend. This is what the software engineers focus on. They don't focus on prompt engineering. People can write whatever they want. You can teach them whatever, still they will write and do mistakes or whatever they want to do. It is you who have to make the best possible answer out of the given prompt, isn't it? So in this session, we are trying to look at the flow engineering part of it, not the prompt engineering. Prompt engineering is like, okay, making stuff and how you ask. If you write more, put more examples, put more scenario, you can get better answer. That is a better prompt. You have to give more time. You have to do structuring on your question, on your query. That everyone knows. But how do you do flow engineering? That means how do you make sense of this asked question and provide the best possible relevant, contextually relevant answer is the main challenge. That is the challenging part for a software engineer, right? So let's try to see that, isn't it? Before we start, I hope I have given you a high level overview of encoder, isn't it? Everything is based on currently the industry is using transformer architecture. Those who did not use transformer have become irrelevant. That means Siri never used transformer became irrelevant, right? Because it was developed by Google, so Apple didn't use it, right? And so they became irrelevant, just like Nokia. They didn't use Android and become irrelevant, isn't it? So you have to also, see what is coming and you have to accept it. even if it is your rival that actually developed it. And now Apple and Google have planned for a tie-up. They have tied up already so that Google's AI models will be installed in the Apple's devices. If you don't know, then you can look through it. That they cannot develop AI anymore. Apple cannot do it. So they have asked Google to set up everything in Apple's phones, in the upcoming phones, upcoming tablets and laptops, right? Apple has been promising from the past 3-4 years, if you know, AI intelligence, this, that, but nobody in Apple is able to do it. So they have tied up with Google. Samsung has also done the same thing, tied up with Google and improved their AI experience. And Apple was left behind as compared to Samsung. Samsung has better experience than Apple. So not to get left out in the race, they also tied up with Google, isn't it? So you can read more on this blog, on this story, why this is happening, because they are using rule-based model. When from the past, you ask something, it will give you the same answer. That is not how people want nowadays. Nowadays, people want small language models at least, or at least the Gemini models, or at least GPT model, something that improves experience to the next level. That's what they want. Okay, so voice quality has dropped. Okay, is it true? I don't know. The graph on my audio graph is not looking good. So I don't know. Uh, some setting change has to be done. But anyway, is it good enough, or should I switch to the webcam mic? Good enough, right? Okay, fine. Okay, so let's look at this flow engineering part. I have given you some high level encoder stuff. I was going into the story mode, but let's not go to into the story mode, right? What has been happening? If you look around you, then you will know what has been happening, who is profiting, who is going up and down, right? Yeah. Apple is just running on the emotional essence of it, but the product quality of Samsung has improved a lot in the past. Way back in the past, it was not that great, but now it has improved a lot. Yeah, so everyone is trying to accept the new reality. Encoder here, I will say that it will take some kind of text and it will output some kind of vector. Let's say it is outputting some kind of integer vector, okay? You can say this is an artifact which is understood by the internal system. It is not for anyone looking outside. If this information has to go outside, then it must pass through a decoder. Let's just assume it like a black box, right? This in itself involves like 6 sessions in the live sessions, which will be 1.5 months almost, just to understand the encoder decoder and to code the encoder and decoder ourselves right from scratch. Because if we don't code it, then just studying the theoretical part is not good enough, you know. So let's just try to treat it as like a black box and try to go to the next part, which is about which is about uh, how do you eliminate hallucination, or how do you reduce hallucination, mitigate hallucination. There are many techniques. Okay, there are many techniques, but in this session, we are just going to look at one technique. There is human feedback technique, RLHF technique, and many techniques are there. But we are just going to look at the retrieval augmented generation. Before starting, let's try to understand high level what is a retrieval augmented generation. In this case, whenever you are asking a question, let's say the question is going to some LLM, you are asking a question, some kind of query is coming. Okay, the LLM will try to give you an answer, but attached to the answer, there will be references to each of the chunk, that means each of the part of the answer. And that will be coming from some database at the backend, which is your vector DB. The vector DB allows indexing for fast searches. If you know it, the HNSW is the industry standard that is getting used. Hierarchical navigable small world. This is the industrial standard at high scale. Okay, if you don't know it, just think like it is some kind of indexing from where it is fetching to the LLM a part of your answer. Like let's say this is your answer. The answer has different parts. Here you will have reference 1, reference 2, reference 3, reference 4. These references will be given from the DB. So to your query, there will be some answer. Attached to that, you will have a reference. each part, so that if you feel like, oh, why did the LLM answer something like this, then you can actually check out the reference and read the entire document. There is always a proof attached to it. Okay, something for which the answer is not present in the DB. The data is not present in the DB. The LLM cannot put such kind of answers. Even if it has options, even if it sees there is some good chance of something happening, it will not put it. So that's my goal. That's my goal. Yes, there can be some issues. We will talk about the issues later on, but let's say that this is how I try to reduce my chance of errors. Are we good? Okay, if we are good, then let's dive into this entire process a little bit more. Let's try to dive more into this. Okay, the query comes to not exactly an LLM, it comes to an agent. Okay, LLM is just the brain of the agent. You know, the main part of the body which actually does the heavy lifting of thinking, planning, deciding, everything. These things are done with by the LLM. So what exactly is an agent? An agent can be considered like a microservice or a process that is running. But there are many other microservices that is present. Okay, like a body. A body has an entire soul that is the agent, and the soul is actually driving each of the body part to carry out their action. If you want a passport, you will contact an agent and ask for the passport. Agent is not the one who is making the passport, but he knows whom to call, whom all to coordinate, and what all job to give everybody to get your job done at the final end, right? So you as a guy, you just know that I will call this agent and I will get my job done. That same agent concept, when you put in the design, that is your agent's service. When it does this work automatically means autonomously, I should say, in a sense that you give the job, you just gave a job, a full high level goal. It is the agent's job to divide that further into sub goals. That you want passport, okay? Agent has given you a quote of 10,000 rupees. It knows that he has to pay 1,000 bribe to this guy, 500 bribe to that guy. He has to give 2,000 money to this person, that person, coordinate this that way. So he knows about the sub goals of one goal that you had given. It will divide it into sub goal. It will try to see that each of the sub goals get completed in their given time. The output of a sub goal goes to that particular person where the input is required. The output of one guy is the input of the other guy. You take the signed paper from the gazetted officer, that is the output of the gazetted officer, going to some another officer, that if that is signed, then I will proceed with my work, isn't it? So you see, it is kind of a pipeline. So we will try to design here a pipeline, which we will try to see how a query comes and how it goes through the entire pipeline to produce the output, isn't it? That's what should be your goal to understand as an engineer, right? So at a high level, you can understand that you gave a goal, he will say that I will give you after 2 weeks. There will be no prompt back from that agent about anything more. He will just get all the information right in the beginning. It is his problem to divide into many sub goals, see how it is coordinated, what is the output, is the output good enough, what I have to do, I have to retry, self evaluate. So many things are there. If he is carrying out everything autonomously, so such AI system is called agentic AI, agentic AI service, right? Okay, so you know what is agent and agentic AI service, or and if it provides reference to whatever action it has done, that there is a reference to it. There is some point I referred. There is a manual. Using this manual only, I'm doing my job. I'm not doing whatever I want to do. I have been taught this thing in my MBA. I have been taught this thing here and there. These are the books and these are the reference points. If he's trying to use that thing, then such kind of agentic AI is called agentic AI RAG, or simply agentic RAG. Okay. Because now you are providing reference to it. So agentic RAG is a subset of your AI, right? Agentic AI can be a larger part, agentic AI, and your agentic RAG will be a smaller subset of your agentic AI, because in agentic AI you may provide reference, you may not provide reference, and everything comes under AI, right? So this is just a high level overview of what we are looking at. We are looking at a agentic RAG with reference. Everyone wants reference. Okay. Let's try to see a very high level pipeline. We will draw two pipelines. One will be high level, then I will be explaining, and then I will be breaking it down side by side. Okay. So if a query comes, what should be the first step? First step is to convert the query into the format that the machine understands. That is the encoding process, isn't it? When the query comes, you have to pass it through an encoder. This is called query encoding. When the query encoding is done, you may have to try to make sense of the query and try to take out the data. Right now I'm drawing very high level, so you will find a lot of points are congested into one point. But what I'm trying to draw is, let me just draw a very high level diagram so that you can make some sense out of it, what I'm trying to draw. uh, if I can make use of this thing, agentic AI service. Agentic AI service, this is one of the microservice that is present. The user will send the query to the agentic AI service. Okay, the query is coming to the agentic AI. Then this will go to the retriever service. Retriever service job is to get the information. And where is the information kept? In the vector DB, right? Let's keep the vector DB here. The information is kept in the vector DB. This is good for storing embeddings. It can actually take the information from the vector DB. It can ask the retriever service. Retriever service can give the top K results. Top K results, or whatever is the sampling process, whatever it is. We saw this already. It will just return those things, whatever is the top K document or whatever. Then this will give to the LLM service. The LLM service will take both the query and the return documents, the top K documents, and it will try to make sense out of it and return the value, whatever is the result, and then the result will go to the person. This high level structure I want to understand more in depth. Okay, how it is done. So this is the high level structure. Okay, now we will go two levels in depth. The first level is when the query comes, then it has to be encoded. It cannot just go to the retriever right away. Okay, it has to be encoded. So there will be an encoder in front of the retriever, right? Now the retriever is connected to the vector DB. Vector DB, VDB I will write. It will take the top K results. Let's say it has searched for the top K nearest neighbors. It can do approximate nearest neighbors. That means if I have given one query like I want a round neck blue t-shirt of M size, then it will try to take the top 5 result. If I'm looking for top 5 result, it should have round neck feature. It should be t-shirt, M size, brown color or whatever color. If I don't have enough result, then what result should be there in the top 5? Those things it will do from the vector DB, right? Those results are taken, whatever has to be, whatever is relevant for top K. You can understand vector DB as where the in an n-dimensional vector space, you have many points present in the n-dimensional vector space. Many points are present, right? If your query comes in, its embedding will be calculated, and let's say this query sits in here. If I want to return top 4 result, which are the top 4 nearest neighbors as per your query placement? That is what is my goal. Okay, so when I say that the query is converted to a vector, let's say it is converted to some kind of vector embedding, and you will place that embedding into the vector space, n-dimensional vector space. Here it is 3-dimensional vector space, and you will find who are the nearest neighbor. This is done with an indexing technique, HNSW, which is hierarchical navigable small world. You can go with the simpler techniques like cosine similarity, flat indexing, KNN, or inverted file index. Those are some different techniques. I just covered this in the morning class if you were there, right? So you might now relate it back to this class. But whatever indexing it is there, it will try to find the top K result and try to send it to the retriever. This is a part of the design classes, right? And this what we are doing is not a part of the design. I told you it is out of scope there. So here now you got the top k nearest neighbor. What to do with this top k nearest neighbor? The retriever's output is a sorted top k nearest neighbors, sorted in the relevance order. Maybe it is based on the distance value or how dissimilar something is. Let me tell you about something about cosine similarity. You know, if there are two vectors, let's say vector A and there is vector B, and if you want to find how similar they are, you can simply do a dot product. A dot B equals A's scalar multiplied by B scalar cos theta, right? So this cos theta term is your actual similarity that you are calculating. So cos theta is equals to A dot product with B by A's value and B's value. Okay. This is your cosine similarity. I have just shown you in two dimension. In multi-dimension, it will come to, some multiplication formula. It will go over n dimensions. I'm just showing two dimensions, so there is only two things. If you do dot product in two dimension, n dimension, it is similar way you have to do. Now, this is a part of linear algebra, right? And geometry. So we are not covering it here. But anyway, I think you will get it easily. It is a dot product function. So that's how you find similarity. Similarity of triangles, right? These two triangles are similar. They don't have to be of equal size, but the angle should be same. If all the angles are same, they are similar, no matter what is the size. So vectors are also working in the same way. If this is one vector and this is another vector versus this is another vector, this is A vector, B vector, C vector, then A is more similar to B than to C. It is not based on the scalar. It is based on the angle that it is making. Okay. You can use this simple technique, cosine similarity, as well. I just gave you an idea of how to find the top k nearest neighbor. Let's say it is returned. When it is returned, this is not based uh, too much on the query, because I had just placed a query, right? Maybe the query is so complex and fuzzy. Query can not be like, it is a very detailed query. It's not a very clean query. It can be, a vague type of query, fuzzy query. Then the answer will also be like that. Then how do you believe that the ranker process was done properly, ranking was done properly? You can't believe that. Let's say that the top k nearest neighbor k value was 50. You got top 50 nearest neighbor, but you have to return only 5 answers. Then you get top 50 here. You use another service called re-ranker. Now the re-ranker, what it does is it will take the top k nearest neighbors, okay, top k nearest neighbor, and it will try to match each of the query with the document that is returned. That each of the result, that let's say 50 results were there, it will do it will do match with each, I mean the query is same with each of the document 1, document 2, document 3, and see what is the relevance score. It will try to give a relevance score from 0 to 1 and then re-rank if required. Because what we did was we just embedded the query and found out the document. That may not be the correct way to do it. That is just an approximation. This is like more relevant. Now you are making things go into much more relevance. But you know that this is going to take more time complexity. If it is taking more time complexity, then maybe I'll just do for 10% of the points, top 10% of the points, because that is good enough for me. Because an approximate top 50 sorted in descending order of percentage, maybe I can look at 7, 8 points and give my verdict for the top 5. I don't want to look at all the points. So the re-ranker will also take a subset of such points which are most probable according to the retriever, and will try to rearrange them or re-rank them, which should be shown on top and which should be shown on the bottom. Something like that, right? Based on some relevance score uh, calculation. Then this will give to a generator, because maybe the answer that you produced may not have anything to do with whatever you have generated. Maybe the query was something else. Maybe the goal was something else. Maybe you were thinking in some way, but the goal actually wanted you to think in some other way. Generator is the intelligence layer. This will do self-evaluation of the answer that it has generated. If the self-evaluation passes, then you will see an output. Then you will see an answer coming to the user. If the self-evaluation, however, fails, then again we have to go back to certain step based on what you think has failed. Have you got the wrong documents, or have you re-ranked improperly, or is the goal setting was not proper? Or is the planning not done properly? In this case, all these things are not shown. I will show you in the next diagram. But this is giving you an overall high level idea that first we will try to encode whatever query is coming. Then I will try to take the top k nearest neighbors based on approximation. Then I'll try to re-rank all the results. Then I'll go to the generator where I will be having self-evaluation, checking, because this checking is important. This checking is important based on reducing my hallucination and not just spitting out anything that I want to say. Just being more conservative, right? And if I think that something has failed, I'll go back to that step and reprocess that step in a loop until I get a satisfactory answer. Now you can think that the intelligence layer, the generator, will be on the LLM side. This is the LLM service, generator, intelligence. Wherever the brain comes, there is LLM. Okay, the less brain lifting is done by the others, but the more thinking, reasoning things you will find in the generator. If you turn on the reasoning mode on your GPT, you will find what it is thinking. It is talking to itself. The GPT is talking to himself. So this user has asked this, so he wants maybe this thing, that thing. Those are all reasoning things getting done at the generator, even before giving you the output. It is trying to evaluate. It will also rewrite those evaluations if you see properly, right? If you see, it will reevaluate, it will get some result, then it will again talk to itself, again it will reevaluate. Those reevaluations are going in a loop with the retriever. Okay, that what it is getting and what the user wants. And when it concludes, then only it will give the final answer. If we are good with this point, then we can go into more detail. Tell me. Yeah.
Yeah, my question is, here you were saying that we are getting the top K. I'm audible, right?
Yeah, yeah.
Yeah. So we are getting the results from vector DB. It comes to the retriever. Then we are
Mhm.
sending the top K results to the ranker. And there we are comparing against some documents. So what is that document? I did not understand.
Document is the return value of the vector DB because we cannot just take embeddings and match it
Yeah.
with the exact query, right? The embeddings are used to take out what will be the top K reference points. The vector DB indexing is
Oh.
done on the vector embedding, but the document is also kept somewhere, right? But when you want to match the exact context of something, you will not be able to make a lot of sense from just the vector embedding. Yes, it is done to search on some parameter.
Hmm.
But if you want to do deeper contextual analysis, then I think just having that high level integer value is not good enough for producing better answers. That's what I'm saying. So you need some reference from the document as well, like what the
Hmm.
document contains, or maybe some summary of it. Maybe you can go through and just get something done, right?
So, yeah, so vector DB is giving me the embeddings, which is the numerical values, right?
Hmm.
Where do we store
Vector
this?
DB is giving the yeah. Vector DB is giving me the top k nearest neighbors, not just the
Hmm.
numerical. Because we are not interested in embedding. We just created embedding to do faster search on the vector DB. I'm interested
Okay.
in the document and the exact answers, right?
So document is coming from this vector DB only, right?
Yeah. So let's say that you have a MySQL DB.
Yeah.
When you have to search something,
Hmm.
you want to use B plus tree, let's say for
Right.
index.
Yeah.
You want to do searching for that, then whatever information is required to search the which document should I search or which key I'm looking for, that B plus tree will tell you which key we are looking for. But it is not storing the document, but a reference to the document that is kept somewhere, right? Vector DB also works
Yes.
in the same way. It is
Okay.
having its
Okay.
own structure, the graphical structure, as I said, HNSW, but still it has its link to the document, just like MySQL, right?
Okay. Got it.
Yeah, so similarly, you will have the documents as well. It's not like you just know. If you know where the document is kept, you can take it whenever you want because everything is happening in the same place, right?
Yes. All these informations are passed to the re-ranker. So
Yeah,
yeah.
yeah. The re-ranker knows about what is the sorted. It will send this sorted top K to the re-ranker. Sorted top K means that maybe the cosine similarity was one of the values. In the cosine values, what you can get from -1 to 1, you can get. If you have uh, cos 0 degree, what is cos 0 degree? It is 1. That means these two are similar, equal, or you can say that it is overlapping. One vector is overlapping the other. Minus one means you are just in the opposite direction. Orthogonal means 90 degree, you will get zero, right? That's how you calculate how similar two vectors are, simply. So those sorted order based on this cosine similarity can be given. I just gave you one technique, cosine similarity, right? Yeah.
Yeah, so this re-ranker, when it is doing the relevancy check with the query,
Mm.
it should also be in the terms of embeddings, right? We can have a different technique, a different model here, which is acting like a judge, but the
It can
re-ranker should
be,
also be in the
yeah, that is
embedding.
true. It can be in the form of embedding, but it doesn't mean that we don't have the exact query or we don't have the exact document.
Yeah,
If we
metadata
require
will be
the
present. Mm.
if we require the document, it is there. If we need embedding, also it is there. Even at
Okay.
the vector DB, when I say vector DB, it is just the indexing purpose which I'm showing you, that it is a graphical index. But it
Mm.
doesn't mean that the data is not present anywhere. Data is also present, right?
Yeah,
Yeah.
makes sense.
So I think we can go to one more level in depth of this pipeline we can build, right? So this is just very high level thing. Let's go to the next part of it. Yeah.
So just to confirm, Surya, embeddings is different from encoding, right? The values, numerical values get.
Yeah, they are different. Encoder can do any kind of encoding, but when I say vector embedding, it is just one type that I'm imagining, because I explained you in the morning, right?
Yeah,
So I
yeah.
don't have my notebook, but I'll just try to make sense that uh, I had given you one example. What was that example? The movie
Mhm.
was funny, something like that. And let's say the movie was uh, the movie kept me laughing the whole time.
Yeah.
Kept me laughing the whole time. The whole time. Then I said that if you want to create attributes out of it, what can be the attribute? Maybe how funny it was, maybe one of the attribute. This is video one and this is video two. Video one, video two can be one of the attribute. Maybe on the fun part, this is 0.8 and this is 0.95 on a scale from 0 to 1. Maybe the quality can be one of the attribute. Which one is a good quality? This may be quality wise 0.9 and this may be 0.7. Maybe on the brightness side can be one of the thing, that maybe somebody was some video was more on the nighttime recording and some was more in the daytime recording, and maybe the brightness can shift because of the night and daytime videos, right? So if this video 2 was in the night time, then this can be 0.5 and this can be 0.8 if it was in the daytime. Maybe some other features can be added to it, right? Okay, some other features can be added. How much horror did you find? Funny was one thing, horror is one thing. It can be fun as well as horror. Can contain fun and horror. Maybe on the horror scale it was 0.5 and on the horror scale this was 0.1. All these are adding up one dimension to the vector. So when you say that this text has to be converted to vector embedding, V1, then its vector embedding based on these four dimensions or four attributes will be 0.8, 0.9, 0.8, and 0.5. This is what we learned, right? This is what the embeddings are, and it will be based on n dimension that you identify simply. It can be any hardware feature, it can be whatever you can think of. We do feature engineering to also come up with some new features based on the data set, right? Those things are also there, feature engineering. Okay. So
Yeah.
encoder doesn't mean that it will just do vector embedding. It can do a lot more things. Like there is a byte pair encoder. If you read about it, there is a byte pair encoder. The byte pair encoder, what it does is it will take the English word, it will do slicing on the words so that it matches up with some vocabulary, and then convert each of the letters, I mean not the letters, but each of the subword into token IDs. Simply like convert word to integer. How to do that? That is also done with the encoder. But is it vector embedding? No, it is not vector embedding, right? So encoder is more general thing, isn't it? It is more general idea that we are looking at. Okay. So let's get back to our pipeline, isn't it? Okay. Yes. One more question.
Can you show that previous slide?
Previous slide. This slide.
No.
Okay, this slide.
This one.
Okay.
Both are related to Agentic RAG, right? Both
Yeah, that
diagrams.
is what we are seeing entirely. Everything is in
Okay.
the same thing. Uh, we will make the final pipeline, then you will understand probably. So this entire class is on the same topic. Okay.
Okay.
Yeah, let's try to do a little bit more than what we have done right now. Yes. Banu, your video seems off.
Hi, Surya. So, Surya, I'm just curious, right now we are talking about embedding. So, like, it is always guaranteed, our model will always, so let's say, like, we are using some embeddings for, right? And will the performance of a RAG system may degrade due to embedding, or it will be constant
That
throughout?
deviation part we will see at the end because there are
Okay,
many
okay.
cases because of which it can deviate. So, and
Mm-hmm,
there are many categories of it too. But let's keep
mm-hmm.
it to the last part, right? Let's
Okay,
first design this pipeline, then we will go to that part. Yeah.
yeah.
Okay. So let's start the process. Okay. So what did you understand about the retriever at a high level? Can you tell me what did you understand about retriever?
So basically, in the retrieval pipeline, so first, like, we uh, do the chunking of the documents and then store it inside a vector database, and with the
Mm,
help of embeddings, we do similarity, and based on the similarity, like, we take out top k chunks, and then we have to again do the filtering of the chunking and do the re-ranking.
yeah. Yeah.
And probably in the re-ranking, we need to do some MMR kind of thing, where, like, we just need to keep only the relevant chunks,
Mm,
and then
yeah.
only we are
Yes.
going to going for
Yes.
the generation.
Yes. Okay. So this is what we have seen till now. Let's try to see each of the parts separately in a little more detail, and then we will combine all the part together. So right now I'll be showing you without diagram, without extensive diagram. But let's try to understand each of these parts, and then I'll combine it into a single pipeline. Let's talk about the retriever. That is the first point. The retriever. Let's go to the next page. Retriever. As he explained, we are going to take the top K. Let's go ahead with the cosine similarity because you understood what it is, right? There are many other techniques, but let's go only with cosine similarity for the time being. Okay. It is the easiest one to understand. Okay. Now, in case of the retriever, I said that there is an encoder. There are actually two encoders present at the retriever, not just one encoder. One encoder is present for query, and this is called query encoder. And one another encoder is present for when you want to store something into the vector DB. You want to populate the vector DB. Then this is another encoder for the data that is incoming, for the documents that is incoming. And here you have the retriever. It is inside the retriever, you can say. And on the other side, you have the DB, the vector DB. Why we have two different encoders and not the same encoder? Because the nature of the data is different and the query nature is different. Query is about asking a question to something. Document can be a big amount of data that you want to compress and store somewhere, right? Both the strategies can vary. These two are encoders. Okay, that is true. They can be from the same family of the transformers, let's say. Same family of transformers we have taken. But even if they belong to the same family, they might be tuned in a separate way to do something else, to carry out some other task. Once this encoder, one's job is to take the query and maybe make it more sensible to be able to search on the vector DB, whereas the other encoder is for the storage, not for searching. And even though it is for storage, it is for the document, not for the query. Okay, the query is something that we are not storing. So since they have different strategy, even though we are using same family of transformer, we will be probably using different tuning on these encoders, even though they have the same base model, right? So that's why we will be using two encoders here. There are two encoders in the retriever, and it is called a bi-encoder. Okay, so retriever has a bi-encoder. The output of retriever is always an ordered set of top k nearest neighbor, which is an approximate nearest neighbor, right? Okay, so till this point we are clear. Okay. Why did we go with the vector embedding search? Because it does semantic similarity search much better than any other present technique, semantic searches. That means meaningful search. If you want to search puppy and you have dog, they will be very similar in the semantic search. In the other searches, many such things may not come very close. So that's why semantic search makes sense, makes a lot of sense. Okay. Okay. Can you tell me what can be one of the problem of retriever? I told you right now, but I didn't tell you by force.
So one thing is like the chunking could be done with a different model or maybe with a different dimension, and the retriever could be using some different dimensions. Or
Okay, so let's say that the dimension will always be, uniform. Even if you don't have some inputs or you cannot identify, you will do padding for those dimension. So dimension is something because there are padding options present in your code. You can always add padding to everything to make everything, yeah, all the vectors come to the same size, and everything will be served exactly with the same dimension of the vector. But the problem here is the solution what the re-ranker is doing. The context with the query is not good enough. That's why we have the re-ranker in place. Otherwise, if I say that the output here is already descending order top k approximate nearest neighbors, then why do you need re-ranker in the first place? The re-ranker is needed because query to each document matching is not good enough in the retriever, isn't it? So why we put re-ranker is the drawback of the retriever. But it is fine. We can just put one more service or one more component after the retriever so that some separation happens, separation of responsibility, as well as this answer is good enough for me, right? If I attach too many things into one algorithm, then that algorithm becomes more complex and maybe the results will not be very good. Okay, so we want to do separation. So that is one of the problem, right? Okay, let's say that we are going to the re-ranker. Re-ranker. Re-ranker has cross encoder. The retriever has bi-encoder. This has cross encoder. Cross encoder means it takes two different inputs and try to compare at the token level. Like let's assume at the word level, it will try to compare and do interaction at the token level and see how similar or dissimilar they are. That is called cross interaction. And cross interaction between two items, the query and document, is done using this encoder. So this is called cross encoder, isn't it? I think it makes sense now because it takes query from one end, document from the another end, D1, D2, D3, and it tries to see how relevant they are, score something to the document that this document has 0.5 score based on the query. Document 2 has 0.7 score based on the query. So maybe the sorting order that retriever has provided D1, D2, it should be D2, D1 based on the score that I have given after this cross interaction, D2, D1, right? So that is what re-ranker is doing. It is doing cross interaction at token level using encoder and trying to give some score, relevance score. And that is what is the cross encoder's job. It is the re-ranker's job. Okay. Let me give you an example. Maybe that will clarify more stuff for you. Let's say that if we have asked about Apple's financial growth, okay, I think it makes sense that we are asking about Apple company's financial growth. Okay. Maybe the retriever has taken each of the token, Apple, finance, growth, whatever it has taken all of these important words side by side, and it is finding out something which matches with Apple, something which matches with growth and finance. Maybe it can pull out some document about finance. It can pull out some document about apple tree growing. Why not? You can have you can have in your DB, right? Apple tree growing. So maybe there will be some output called how to grow apple trees. How to grow apple trees. You know that the root word grow and growth is present there. How to grow apple trees. So grow is present. Apple is present. Two word matching should be getting a higher rank. Let's say it was given rank 1, isn't it? Let's say it was given rank 1 based on just the token level matching. It is doing token level matching. Based on token level matching, you are showing how to grow apple trees rank 1. Okay, there may be many other things, and maybe at some rank 4, rank 5, you can have financial uh, report of Apple as a company. You see that what is the difference? Grow is present, grow is not present. Okay, here what is matching here? You can see that financial is present here, financial is present here, and maybe Apple is present. So somehow the ranker gives that rank 1 rank 1 should be given to this and the rank 4 should be given to this. Why not? It can happen. It can happen. But what the re-ranker will do is now it will match with the asked query based on the context level analysis. And it will see that this is asking about financial growth of Apple. It is not asking how to grow apple trees. So it will give different relevance score to something. Let's say it gave it 0.8 and it gave it 0.3. Then maybe a re-ranker will shuffle everything up and down. And based on that, a report will come. Unless you match this output, just if you do token level, it is not good enough. Tokens are matching. You will say more matching means better rank. It may not be true all the time, right? Okay, unless you match query with document side by side, do cross interaction, you cannot get more refined answers. So this is trying to do more refined analysis and give better answers. Right, I think you have got the idea what the re-ranker job is and what is cross encoder at high level. Okay, then what is the next thing? The next thing is about the re-ranker will be very high in computational cost. So you will not be doing it for all the queries that are coming from retriever. Not the queries, but I will say the documents or answers that are coming. You will just do on a subset of the answers that are coming. It takes a lot of time to do this, right? Latency is one very important factor for us. Okay. It will go to the generator. Generator. Generator is your intelligence layer. Let's try to see what happens at the generator. Let's try to break it down. Okay. In this entire workflow, which I will show again, in this entire workflow, what has happened, which I have not shown here? What had happened? First thing, whenever the query comes, you have to do some kind of query analysis. That what is this query about? And maybe some kind of intent extraction. This has to be done right on top, which I have not shown right now. Once you have done this, then you should seek some kind of query decomposition. Let me go to the next page and show. So query analysis plus, what did I say? Intent extraction. Query analysis plus intent extraction. Let's say that I was asking a question. Let me write the question. Compare the 2025 revenue of company A and B and explain why B's growth slowed down. Okay, I think the query is clear, right? Compare the 2025 revenue of company A and B and explain why B's growth has slowed down. This is the query. What this will do is the query analysis and intent extraction, it will break down into meaningful sub sentences, you can say, or subqueries. What it is trying to do, it can think like, okay, what is the user's intent to get company A's revenue for 2025, get company B's revenue for 2025. Okay, and then it wants to look at the market analysis of company B. This is what is the meaning of your query, that the query analysis and intent extraction will try to take from your given query. I think it is clear, right? where it is going, where these things will go. This will go into query decomposition. Query decomposition will try to make sub goals out of your given full goal. That what query should be sent to my internal services. You have given your query. If I direct your query directly, then the answer quality will not be good enough. So what should be the sub goals that I should make, and I should send to my internal services to get better answer out of my understanding of your query. Okay. So what should be those things? So let me give you one example. Subquery number 1. Company A report 2025 for the total revenue. Total revenue. Or you can say total revenue report of company A for 2025. Subquery 2, company B's report for 2025 for the total revenue. And then subquery number 3 can be internal memos, because you need proof. Internal memos regarding company B's sales decline in 2025. You need that proof from your DB, right? So you are trying to search for internal memos regarding company B's sales decline in 2025. That is your query decomposition step. Now you have converted your plain and high level query into more meaningful query, and after that you have given multiple goals. Where will these multiple goals be going? It will be going to a system who will be orchestrating your retrieval, which is the retrieval service. We will write here orchestrated retrieval. Each of these subquery will be served again and again, one after another. So whom will the query be served to? Vector DB. From the vector DB, we will serve each of the subqueries and try to extract the answers. Okay. But is vector DB good enough? Maybe everything is not available at the vector DB. You can have multiple sources. The retrieval service will have many type of APIs that it will connect to. Vector DB is just one of them. Maybe you will have a SQL DB as well, from where the numbers will be taken. Maybe you will have a web search API too. You will find it in the GPT as well. If you search some question, you will be seeing some web search happening, something being pulled from the vector. Maybe they will not write vector, but if they are doing web search, they will be writing it. They are doing it currently, right? And from what sources they have taken, they are also writing it. Right, so that you have some proof of why such kind of answers actually came into existence. So you can have many type of this thing. Vector DB can be used for, let's say, your general knowledge. Whatever you have trained on, based on that, it is trying to answer. Internal memo is in the vector DB. SQL DB can also be in the internal memo, and it can be more like a precise revenue numbers. Revenue numbers are stored in the SQL DB. You can have precise revenue numbers. Then you can have web search API for regarding any kind of news or any kind of whatever discussion is happening, right? The market analysis, some recent news on this company, why it is under decline, some expert, what the experts are saying. It will try to pull those information. So you have many different options to pull the information. That is what the retriever will actually try to do, not just try to take from the vector DB, right? Even though I had showed you in the past that it is the vector DB. Then you have, in the next part, you have the self-correction and reflection, or I will say self-evaluation simply. It will try to check that whatever answer I got, is it actually correct based on the given query? Have I attained my goal? If you have attained your goal, yes, you have attained your goal, you have passed, then you will get the answer. If you have not passed, then you will go back to the step which you feel was not done correctly. It can be any of these steps. It can be like, you know what, you didn't use, I mean, you used the wrong API for something. Like, let's say there was a calculator API with you, but instead you used the vector DB to calculate some complex math calculation. That is incorrect. You should not send math calculation to vector DB. You should send it to the calculator API. So using the wrong API at the wrong for the wrong job can lead to some not so good answers, or maybe bad answers, illogical answers. So maybe have you done any error in this part? If you have done any error, then you will go back to the orchestrated retrieval. You will try to retrieve it again. Or have you actually not got the subqueries correctly? You will go to the query decomposition. Or have you misunderstood the query? You will go to the query analysis. Based on what you feel, what this evaluator feels, it will send back to that particular service or step and you have to repeat. So this is going in loop. This is going in loop until you are satisfied enough and give your answers. Okay. Does it make sense? Does it make sense? So this is a high level overview of our pipeline, what we will be trying to do. Right. I hope we have got to the point. Let's try to do something with this. So now if I make some diagram, then maybe it will make more sense. Let's try to do something. Yeah. Let's say that the user is coming and you know the diagram for this, where is the agent and everything, right? Where is that diagram? Yeah. This is the diagram. So you think like the agent is always in play. It is the main orchestrator of the entire thing. Okay, the LLM will do all kind of reasoning work. All kind of evaluation reasoning will be done at LLM. Retriever will do all kind of taking the top key items. Okay, and sending it back to the agent. I'll show you in the pipeline which is which part. So let's get started. We will do query analysis. Let me make this a little smaller. Yeah, so we will do query analysis plus intent extraction. That is my first part. When I get the user query, right? We get the user query. Query is Q. Query analysis and intent extraction. Where should it go? Query decomposition, right? Query decomposition. You know what they mean because I have already explained you what they mean exactly side by side. It should go to some kind of planning phase. Once you have got your exact goal done, then you should be planning on how to achieve such goal. Okay. These all things are done at the agent. By the agent. Okay. These all things are done at the agent. Then we will be going to some query encoder. Let's try to see the query encoder. Query encoder. I'm taking too much space here. Query encoder. After the planning phase, the query will be fetched to the query encoder. You know it is present on the retrieval's front end, right? Before it goes to the retrieval, then you have the retriever. Retriever will take the encoded query and it will try to take the top k from the vector DB. And what it will return? It will return the top k result. So top k nearest neighbors. It will try to send it to the re-ranker. It is sending the top k nearest neighbors. Okay, it is actually approximate nearest neighbor. This is an optional step. You can actually output. This can be taken for the premium members. It can be skipped for the free members, something like that. Okay, why do you want to do so much of processing? So you will see that with the same model, you will get better answer if you pay the money and use re-ranker. If you don't pay, use the same model, you don't get such answers. So this is also one of the reason for that. Okay, that re-ranker is optional. Okay, after these all things are done at the retriever service. Let me keep different color for it. So retriever service. Retriever service. Then let's go to the next step, which is the observation. Observation is what is your answer currently and how should I proceed in forming the answer with whatever result we have done. It will observe, it will try to formulate some kind of answer and it will try to give it as output to the self-evaluation. The self-evaluation is a step which will try to ask question to yourself, do self-introspection about the question, that whatever you tried to achieve, have you achieved it? Have you achieved it? Now this is done at the agent. So let me just, should I change the color or keep the same color? Let it be. This is done at the agent. Then after this, everything is in the LLM. That is a self-evaluation. The LLM will try to do reasoning. It will try to do reasoning on the things that it has seen. So self-evaluation. And after that, if it passes the self-evaluation, then it goes to the final context assembly and answer generation. Because what you need is, you need a final answer, okay, and all the chunks should be having some reference points. But before putting everything together, at least you want to check if everything you have seen is good enough to actually output as an answer, right? So that was the self-evaluation will do. This is in the LLM service. So all the thinking part is in the LLM part. Okay, the planner is your agent, because as you know, in real life also, if you submit a job, the agent will be the one who will plan what has to be done and whom should be given what job. So it is more like a manager. If you think at a high level, think about a company, Samsung. If you think about Samsung, then the Samsung's CEO will be the agent. CEO will be the agent. And there are many departments, like networking is one department. You can have on-device AI as another department, research as another department. CEO will know that if something needs to be done, then how should I break down the goal? Who should be taking what responsibility? And everyone will be talking to the CEO, and the CEO will be the one who manages the entire company's, workflow, everything, how it should go. So this will sit somewhere on the top, that everyone has to talk to the agent, but agent is not the one who is doing heavy lifting. It is the one who is doing more kind of a delegation task. The biggest job that it is doing is the planning part, the query decomposition and planning. That's the most it can do. And after that, the LLM is the one that is doing the more, reasoning part of it. Other than that, everything is fast. The heaviest time that it takes in the self-evaluation, because in self-evaluation, you have to check everything if it is correct or incorrect. And then this can again follow you back to some step where you might have seen that it is not as good as what I am expecting in my quality. So go back to step number, planning step. If your planning was incorrect, go back to the query decomposition if you haven't understood the given query well. Right? I think it makes sense, isn't it? So this can throw you back to any step. Second most time taking is the re-ranker. That's why it is also kept as optional. If you want lower latency, you would want to skip this re-ranker. But that is improving the time complexity, right? So in the fast models, you will find in the GPT fast models, you may not have re-ranker. So you may not get the same quality of answer even with the same thing. GPT-4 versus GPT-4o and Gemini 3 versus 3 fast mode and this mode, that mode. Those modes are having these optional things, turned off or something like that. So they can answer faster. Reasoning will always be slower, isn't it? You can check reasoning will always be slower. Right. So this is your agentic RAG. Agentic RAG. This pipeline that you are seeing is agentic RAG. This is the part of your flow engineering that we were talking about in the beginning. Flow engineering is not about how the query is asked. It is about what can you do with the given query. This pipeline does that thing. What can you do with the given query? Query is given and you have to produce good or best possible result out of it. What can you do? This is the engineer's job, right? Engineer can't do anything to tell the user that you change the query. I mean, wish it could be done, but whatever is the query, what best can you do with that is the flow engineering, right? So this is important for software engineers. In the previous cases of the RAG, when agents were not present, like the naive type RAG, In the naive type RAG, there will be no self-evaluation step. You will not find loop structure. It will be fast, but the answers will be like way beyond you, maybe your understanding at some point of time. If I can just make that, your query for the naive RAG will go to the retriever simply. Okay, retriever. Then it will go to some kind of re-ranker, and that is also optional. Okay, maybe the re-ranker step is also not present. And you will go directly to the answer assembly. Answer assembly, that's it. Query injection and answer assembly. And output the answer, output. There is no way it is doing self-evaluation because there is no loop. What can you do with self-evaluation? Do you decide not to answer? So the agentic RAG can actually stop and say that, this answer, I cannot give the answer to this question because maybe I don't know that the agentic RAG can do. But the naive RAG will always give you the answer because it doesn't have that feature of self-evaluation and thinking and saying that, okay, I cannot answer something because I don't have enough supporting document. Okay. Yes, will you have vector DB here? Why not? You will have some kind of DB connection as well. You need it to make it RAG at least, right? To give some kind of proof of your answer. But this will not stop. It will go in just one iteration. This can take n number of iterations. So which one will be faster and which one will be slower? Can you tell me?
Naive one will be faster.
Yeah, everyone is turning off their video now. What happened? Is it late night or something? Okay. So yeah, so which one will be faster? And at what cost are we taking the speed? At what cost are we taking the speed? So
Accuracy.
yeah, definitely accuracy, and that will be a very big problem. You see these two pipelines, there is no pipeline on one side, right? Even the re-ranker is mostly not present on these things. Because once you are going to be inaccurate, then what's the point of re-ranker on the first place, right? So you will find that you give the query, it just takes the document, just gives a basic top K and generates answer. You will find the assembly part, something like that. Okay, so there is no deep analysis on anything that you are doing. Okay, now how this magic is happening? Uh, you may want to see how the transformers are working because each of them has their own transformer architecture when I say encoders and all, right? And how the main part here is how to know about which part of this sentence is more important than the other part. How do you know that? Because what I said, according to what I said, is you will be paying attention. I mean, I didn't even say about attention. I'm saying that you divide it into tokens and each of them will go as input and we will do matching and we will produce output. That's what we understood, right? But that's not how it works. That's not how it works because if it would have worked in that way, then it will not give so much good answers as we are seeing now. Actually, what it does is it has it has transformers which tells about which part is more important and which part is less important. That is the main part to learn here. That is the biggest challenge in this entire architecture because if given a document or a paragraph, how do you know which part or which words and which subgraph, maybe which sub sentence is much more important, much more relevant than rest of the other part? Try to identify them. That is how what is done with the multi-head attention. You have multi-head attention in the transformers. That it tries it in loop, it will try to understand how to identify which part is more relevant than the other, give it more weightage, and that is how you actually come up with better answers. Otherwise, you in the past example, could you have given entire weightage to everything like the apple trees? You can't give everyone the same weightage probably. Whenever you are generating something, when you are reading something, when you are training on something, every word may not have the equal weightage, right? Isn't it? So how do you identify that? What is the technique for this? Everything everything that comes before your usage of LangChain, is about this pipeline, about encoders, about transformers, about LLMs. Only after you understand this thing, you can easily and smoothly use any kind of, backend services, API calls, and because you don't require any discomfortable discussion to understand about why something is happening, isn't it? Yes, you can go ahead and start reading about these things, but it will be like reading from different catches, isn't it? Different places. Okay. Yeah. You have question from a long time. Sai Rakesh, tell me.
Yeah, yeah. So, will this re-ranking, self-evaluation come under guardrailing?
You
Will
can say that
okay,
this is just a guardrail so that you don't go into some kind of hallucination. But this doesn't guarantee that you will not go. This is just reducing the chance. That is the last part of our discussion of what can be the problem with this kind of architecture, right? But we haven't yet gone to the last part. So, yeah, we will discuss that there. It is a guardrail, but it is not 100% efficient. Definitely.
okay.
Okay.
And how we will achieve this self-evaluation? Are we going to call some model which will perform
This is your LLM, right?
LLM model?
Yeah,
And
this is your
okay,
LLM. Your agent sits like right in the middle.
okay.
You have LLM, you have retriever, you have the DB.
So every retrieval output should be fed to the LLM, and then we will be performing self-evaluation and rechecking.
Hmm.
Right?
Yeah. So this is your overall diagram. Whatever you give goes to the agent. Agent will try to do everything, take care of everything, divide your goal into sub goals, do query analysis, or do all kind of stuff, right?
Okay.
In high level, agent is talking to everybody except for the DB. DB will be connected to the retriever. Okay.
And one more question, Surya. So you just told the main important is how we identify which word is important out of input query, right? So like for that, if we input that query to the model, it will find it, right? I mean, do we have separate?
So this is again a black box that you are talking about, right? If we input that to the model, it will find out. That is not how it happens. You have to input this in the transformer. So that's what I'm saying. For understanding how it happens is the transformer's attention explanation, right? How it actually gives different attention to different part of the sentence. That's what I was saying. That is the job of transformers. So where you are not using transformer, you are not able to get such kind of diverse context and deep contextual analysis. That's why people who never used transformer in the first place are actually lagging behind. That's what I told you the story of Apple and Google, right? That's
Yeah.
how they are different. That's
So
how they
again, the top three will come under transformer then, right? Planning, query, decomposition.
see, transformer is present everywhere. Transformer is present in all the encoders. Transformer is there in all the attentions. Wherever you want any kind of analysis, you have that.
Okay.
Okay, so wherever I have placed encoder, I think I placed encoder in most of the places, right? You have transformer. Even the LLM is based on transformer. Then what? LLM's architecture in itself is transformer. GPT is also using transformer. So even though we have different names here, internally everyone is like using transformer,
So
right?
kind of a wrapper, right? Wrapper they are creating on top of base LLM models, right? Sorry.
No, not exactly wrapper. The architecture of LLM is GPT is different. Architecture of different things are different. It's not the same. They are large language model, okay, fine, but internally their architecture differ. What LLM you will build that may not have the same architecture as what GPT is there. Even each GPT's architecture is also different. So transformer is just like one unit that people are using because it is performing so well. Once you understand transformer, you start using it. Then where should you use it and how do you make the entire architecture based on that? Maybe it will not make sense right now, okay? So right now, let's understand that they are different, but internally they are made, or everyone is made from water and this thing. So that water thing is the transformer, you can say. Okay. So there is a question of how to tune the model. Okay, how to tune the model. So generally what people do is they take the foundational model and they provide their own data set, proprietary. They can take any kind of open models which is available in the market, right? Like the Meta's model, I think, is open. So you can take that llama, you can train it on your own proprietary data set and integrate in your own company. So that becomes a proprietary, and that will why do you take foundational model? Because it should first have a general knowledge of how question and answers work, how the language works. The language model must know about the nuances in the language. Nuances cannot be understood if you train it on your data set. It has to be trained on very big size data set on a big parameters that has its own separate reasoning for it, why it is done. But first you should understand the tone of the language. Understanding the tone is quite difficult task. In what tone you are saying something. If you put comma somewhere, if you don't put comma somewhere is different. If you taunt something, same sentence can be a taunting sentence versus a normal appreciating sentence, right? So how do you know whether this guy is taunting or whether this guy is appreciating? If you give wrong reaction at the wrong time, then that is not language understanding, right? That language understanding has to be done on training a huge data set. That is very, very costly process that we will see. Uh, I mean, at some point in the course, that one session is on this thing, that the cost and how much relevant it is. You can search it, like how much relevant is to train a foundational model. Otherwise, every country would have done it easily. It's not that simple. And it is easier that you take a foundation model and then you train on your own data set. What you are doing is fine tuning. You are not building a model from scratch. But that is fine. You take a foundation model because you cannot spend $10 million, $50 million, $500 million in just training the foundation, isn't it? Building a foundation model. It can take a lot of money. 10,000 crore, 20,000 crore. Can't spend that much money. Better to take it for free and then train it on your own data set in just few crore rupees, 1 crore, 2 crore, that's all. And maybe that is also not required. And then it gets fine-tuned. Already it knew about language. It's like somebody already knows how to drive bike, 300, 400 cc bike. Now you are giving him 600 cc bike. What he has to do? Just he had to adjust with the torque and something, right? Otherwise, what he has to do? You already know how to drive car. You have given 50 to 100 bhp more to it. Then easy learning from scratch. He's not learning from scratch, right? That is how the models also work. Foundation model knows about the things. When you are fine tuning, it is not learning anything from scratch. It is just learning the specific thing that you are training. It is not learning the language, right? So that saves a lot of cost. That's what most companies are doing. Take the open source model, fine tune it, make it their own model. That's it. Change their name, right? To Rakesh 1G, isn't it? Yeah, I mean that is cheaper. And then you answer, then that becomes better at answering your internal company questions. And also this saves money. Not only that, you are not sharing your information with some outside company like OpenAI. No need to no need to share your information. That's a huge improvement actually. Why will you share your information with some outer company? They can leak it, they can do something with that. So many companies are also not preferring this as an option.
Um, One more question. Supriya.
Yeah.
So, as we keep on training the model with
Hmm.
our own data, whatever it will have some memory limitation, right? So, whatever the model it get trained in the past, will it disappear over the time? Like,
No, no. So you are just tuning the parameters. It doesn't have memory cost as you are thinking. Uh, if you see the deep neural network, when you see any kind of connectivity between two layers, let's say, there is a function. Let's consider softmax function, one of the simplest one. There is a parameter value. That means if I am taking in the output, let's say I have to consider, let's say it is output, how much should be the weightage of this output, how much should be the weightage of this output, and how much should be the weightage of this output. You are just learning and tuning this value, means you are changing this value. That's it. So if you are overriding some integer value or float values, then are you taking more space? You are not taking more space for that. You will take more space if you build a new model with the different set of parameters. Different set of parameters means maybe you will have more new neurons in that. Then you will get more parameters, and that will consume more space. Yes, but it's not like the same model can learn, but without the cost of space or negligible space, right? Because data is coming, it is getting tuned, data is getting removed. It is just the tuning thing that you are doing, right? It is changing the values. That's it. Okay, so can we go to the failure scenarios? If you guys are ready. How much time has elapsed since our start? Okay, 2 hours gone already. Let's go to the next part. That is what happens at the 10 a.m. session, right? You have enough time. We just keep slowly going. Those who have attended the past 10 a.m. session, they know it, that it keeps on going forever. Okay, let's see the issues. And there are many categories of issues. We are focusing on hallucination, so we will be starting with hallucination issue. Okay. Oh, the first issue is some kind of conflicting info. Conflicting info means maybe you have two documents with conflicting knowledge. One is saying Joe Biden is the current president. One is saying Donald Trump is the current president. Nobody has written any date. Who is the current president? Based on these two information, what will you decide? Will you decide Joe Trump or something? What should you decide? So this is conflicting information. Even though this seems like, oh, this is like it's too easy, right? But this thing can be extended to more complex things where you just have few entries in the database and they both are conflicting because no timeline is given. Maybe both are correct, but if the timeline was given, that would make sense. Timeline is not given, right? Isn't it? So conflicting information can paralyze your output, can give wrong output, and can generate hallucination. Okay, because of that also, the RAG technique cannot just be, a wonderful 100% authentic technique. I mean, if there is some problem with your own data set, it may seem logical when you read it, but while producing the answer, it's not very logical. Okay, then you have self-correction. Self-correction type hallucination. Self-correction means you may have arrived at a decent answer, but maybe you are searching for a better answer. And in search of a better answer, you found the worst answer, right? That happens, right? You got an offer, you didn't take that offer. You are searching for a better offer, and then you end up with a worst offer, isn't it? So this is also self-correction hallucination, right? Right. It's a self-evaluator can lead to that. Self-evaluator can say, no, 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 why you are taking this? You should go to Fang only, right? What you are doing here? Then you go to Fang, and in search of Fang, the company that you got also is gone, isn't it? So that is your self-correction hallucination. 2 points I have given. Again, anyone can inject any wrong information into your DB that can lead to hallucinations, but that is more like a hacking stuff rather than hallucination stuff, right? So let's not go to that. I'm assuming that everything is fine, whatever is present in the DB, and based on that, still if you give wrong answer, then I'm considering hallucination, right? Not on injecting something with the hacking process and then you hallucinate. Okay. Okay, 2 points. Can you give me something about let's say systematic failure Anything, any kind of issue in the pipeline? Loop issues, latency issues. I
The
think you can.
latency are there.
Yeah. So there can be some technical failures or systematic failures. Systematic failures. Now, this is outside of the hallucination. So it is outside of the goal of what we are doing right now. But just extending that answer to saying that you can keep going into infinite loop because of the self-evaluator. Because once you did not take Fang and they give you 2 years cooldown, then what will you will do for 2 years? You want Fang and you cannot appear for it for 2 years. Then for 2 years you will be in the loop, right? Isn't it? So that infinite loop can happen. Okay, in search of better answer. You already know this is the ideal spot above which I will be happy. Below that, if you get anything, I'll not be happy. And you kept deviating from your answer. So that can lead you to infinite loop. A solution can be you fix a hard-coded number. You don't go more than 10 times into the loop. Otherwise, the person will keep on waiting. He gave query, he is waiting only. That shouldn't be done, right? Okay. Some kind of latency issue can be present, right? We have already seen that latency issue is present. It can be painfully slow if the iterations are going longer. It is not infinite loop, but it is, keeping you waiting for a long time. Can it not be present? Yes, we have seen it in the pipeline. Re-ranker is also taking time. Then there is self-evaluation going 5 iterations. Maybe it is taking 20 seconds. 20 seconds is a big time, right? When you want the question and answer. Yeah. Okay. Can you tell me something about the tool usage failures? Something like that? Retrieval or the tool usage failures? Anything that you can come up with? Tool use failures.
Vector DB failure.
Something like, as I said, giving a wrong API call. You wanted to call calculator, you called vector DB. You wanted to do calculation of complex numbers, multiply this, do that. You are asking vector DB to do it. You are searching for news on vector DB. Maybe recent news may not have been embedded there. And what news are you talking about? You search on the web search API, right? The vector DB is not responsible for all the news that is coming. So using the wrong API for the wrong job can lead to failures, isn't it? That we saw already. This is the biggest failure. Then there can be semantic drift. Semantic drift. Semantic drift, when it can happen? When the query analysis is done. Maybe the analyzer changed the wording in a way that actually shows some different goal. You were trying to say something, but the analyzer converted your query into some goal which is not matching up. Then how do you expect the answer to be same? Isn't it? That can happen many a times because maybe that how you have written and the what format it is expecting is not matching up exactly. Maybe you have written in Hindi. Maybe it is not so much well trained in Hindi. All the languages may not be equally well trained. That can also happen, right? Whatever language you use, this issue can always come. There may be always a semantic drift because humans also do semantic drift. You are asking me some question, I'm answering something else. Then you will correct the question, right? That, oh, this is not something I want, this is something I want. So I cannot say this is hallucination because this is the query analysis problem, right? But we put everything under hallucination that if I ask something and I don't get it, then that is hallucination, right? But hallucination is when you have the data, but still you answer me something. And this issue, as we are using it as a wrapper, this issue, wherever it comes, I say hallucination, right? That I didn't get my answer. But this could have happened in query analysis. This could have happened in re-ranking process, that the re-ranking process was not well done. So that the top one rank was not the best answer that I wanted. Maybe the growing the apple tree was the one who came on top, isn't it? So any of this component in the middle can produce something. Maybe the self evaluator passed your answer, which was not good enough then. Anyone can create such issues. Then there can be give up kind of scenario. Give up kind of scenario means if this system, the agent, could not find your good enough answer in 2 times, it will say that I don't know. Let's look at the lead code solution, right? That's what we do. That if we cannot do in 1 time, let's look at the solution, then I will learn it, right? So that's the give up mode. Maybe if you had tried a little bit more, you could have got to the answer, but you didn't try uh, good enough numbers, right? So that is the give up problem as well that is present. Now, this is also not a very fixed answer that when to give up. How do you know when to give up? That's also an issue, right? If you don't give up easily, then you will go into the infinite loop and latency issue. So where to balance this thing? Balance is important. You can have context window overloading. Context window overloading. Because your context window is not a infinite range, isn't it? It can only remember some of the things that you discussed in the past. Based on whether you are using paid service or unpaid service, the context window size can change. And based on that, the answer will change, definitely. Okay. Like people who are able to listen and remember the sentence that the other guy is speaking will give a better follow-up question rather than a person who just keeps forgetting everything that is just said now. And how will you answer? How will you ask follow-up question, right? It will just be based on the last line or the one point that you picked and you made up in your mind that I'll ask this, isn't it? Okay. Can you say something more on the planning side? Planning or intent? Planning and intent side. What can be the issues in the pipeline? Maybe the agent interpretation is not good enough. Agent interpretation, because agent have to interpret everything, right? Maybe the other components are absolutely fine, but what the agent is interpreting is not fine. Maybe the other guy is saying done, done, done. Agent understood that okay, the work is done, but he wanted to say something else. Done, but you need to give 5,000 again. But you didn't listen to it. Maybe you forgot, you willingly didn't listen, it didn't arrive, whatever happened, you just said, okay, done then. Right? So agent interpretation can be wrong. That can be one thing. Uh, then decomposition failure can happen because when you have identified a goal, maybe your sub goals haven't been done well enough to reach to your goal. That problem can also exist. Okay, like this you can keep thinking. If you stick this pipeline in your bedroom, then you can think about a lot of problems, right? Yeah. If this is what is coming in your exam, then you can just think about it. This is just a simplified agentic RAG pipeline, agentic AI RAG pipeline.
Sir,
Where is the AI part here? Yeah.
it can do wrong planning as well, right?
Yeah, wrong planning. So that's what. Without sticking the photo, also you came up with more answers, right? It can do wrong in any of these steps,
Yeah.
right?
For example, we asked to implement a code and it
Hmm.
used some library of Kafka, but we wanted some other library. It didn't give an option and
Yeah,
it just implemented everything that way.
yeah, yeah.
So
That can happen.
that
A
happened with me.
planning issue can happen. When you think about the question like LLM, is LLM equals to an agent? So an LLM is not equals to an agent. Whereas if you have to define an agent, then this will be LLM plus what did we see? We see a control loop, that the self-evaluation loop is present. That is your control loop. Then we will use some tools over it for the API calls and whatever tools you have. Then we will be using memory as well to remember the context. These all things, if you combine, then you can say it is an agent. If it autonomously does this, you can say it is agentic AI, right? Okay. Hmm. So what words should I include in this word agentic when you say something as agentic or agent? what word comes to mind? What it will do? It will have some kind of autonomy, right? That it can decide whenever it is at a decision point what to do. It can do that. It should have autonomy for it. It should be doing decision making, what to do next. When something has been achieved, what to do next. When some option is available, which option to take, which path to take. Then there should be it should have some kind of goal direction, or you can say it should be goal directed. Okay. It should decide its own sub goals and drive to achieve all the sub goals in order to fulfill the overall goal. Then it should be action taking as well, the agent. That it is his job to do action taking. So what you are doing? You just submitted a job and you disappeared. You want your final answer. And everything that some guy is doing who received your question will be the agent. Okay. So can we compare standard RAG with the agentic RAG? Standard means the naive RAG. Can you help me do that? This will be the last topic anyway. I hope you are out of your energy by now, isn't it? Especially if you were there in the morning session as well. Yeah. Let's say that we are talking about the retrieval failure type. How many times can standard RAG fail in the retrieval process?
One.
What do you think?
So 2 times. So one is retrieval and second one is generation.
Okay. So I'm saying only in the retrieval.
One
So in
time.
the retrieval, one time, right?
Okay.
In retrieval, one time. Because it is not a loop structured. Where somewhere I have drawn the diagram, right? This one. There is no loop. If you fail in retrieval, then that's it. You fail in retrieval only one time. Whereas if you do not do good retrieval, you cannot fail many times here. Where is the time? You can fail many times because of the loop. If the evaluator says that you didn't do a good job, go back again and do it. So you will go into a retry loop, isn't it? That's a common difference based on the retrieval. Let's think about something else. Let's think about the accuracy, which will have the higher quality of the top K chunks.
Agentic AI.
Agentic.
Uh, Simply right. You know why it is happening. Okay. You will always do self-evaluation, good enough or not good enough. If I say that the logic is linear versus non-linear, which one has standard linear one?
Standard RAG.
Mm.
It, so this is linear, and this is your
Yeah.
non-linear type. This is cyclic type, right? You can say the reasoner can get lost in its thought process when it is thinking, right? That can happen. The cost, which one can have in terms of the LLM calls, which one will have lower cost, which will have higher cost?
Standard AI is low cost.
Higher cost.
Low.
Okay. Lower cost and higher cost. Okay. You can say like 1 to 2 LLM calls, you can have 10 plus LLM calls here, depending on the case. So which one will have uh, improved runtime? Let's say if I say 3 second versus 10 second, which will have 10 second, which will have 3 second.
Standard will be 2 second or 3 second.
Yeah. So let's say 1 to 3 second, and let's say 3 to 10 second. Let's keep it to this number, highest to lowest, something like that. Okay. So what we have understood is just a very high level thing about this RAG. And yes, definitely we will be rushing to make the agents right away. But we should also, not get lost into the things like we don't study these portions of how this works, right? So some people are expert here already. They will tell me about if we are going in the right direction. But yes, practical thing is one thing that you use the APIs. But knowing this in depth can also help you do some kind of risk analysis and can help you in the trade-off discussions, can help you in the overall design and architecture later when you give interviews, because this is going to be in the interview for sure. It is already there and it is going to be even more prominent in future. So people who have this in their resume or are thinking about putting this into their resume by you doing implementation, Udemy courses and all those things that is there, then you need to know the back end of that too, right? Any question will come flying and that will get you into big trouble, right? Yes, Rakesh, why your video is turning off all the time?
Not all the times.
Okay.
Yeah. So like in traditional database, so we implement some optimization technique to for better performance, right? In the same way, we will be having in vector DB also.
In the traditional data, so vector DB concept is different. Vector DB was made for top K searches using vector embeddings, which is used by the ML models simply. As
Okay.
I said, like with the incoming of the AI, ML, the thing which SQL and NoSQL generally does is specific searches. Specific search means if you want to filter out something, let's say I want to filter on my SQL DB something greater than equals to 10, less than equals to 20. Exact matching things will be done by scanning the entire DB, right? But if I say give me around 10, minus 10, plus 10, around that, we don't have to be hard bound to it, then those are not good at these kind of queries, right? And also those are definitely not good at a lot of dimensions, isn't it? Multi-dimensional space. The one of the major use cases, you don't have to be strict with your boxes like the low and high range. You don't have to give any kind of low and high range. You can just say what is your value, and around that you require 10 more points. Then it will do fast search on that. We saw that uh, in the we saw in the morning, right? That you do flat indexing or KNN, flat indexing and KNN. Let me give you this example for those of you who have not attended. So what was our processor power? 4 gigahertz, right? 4 gigahertz. So let's take 4 times 10 to the power 9 computations per second. Operations per second is my power of the CPU, let's say, one core. Then let's say the data set had around 100 million size for the embeddings. What is present? Okay. Let's say we are doing top K as top 10 searches on a given embedding. If you use techniques like KNN, K nearest neighbors, or flat indexing, or you go with the cosine similarity, anything with the KNN technique, cosine similarity, or you go for the IVF inverted file index, or you go with the HNSW. When you are, I said last week that when you are giving staff level engineering, senior engineering answers, let's say the fraud detection on credit payments, something like that, or some kind of global payments system you are trying to design. In that case, if you want to do similarity matches, your staff engineer answer cannot be like, I will use ML model and I will do top this answer, that answer, right? Then you are gone. That is an SDE2 answer, maximum. Okay. You have to be exact in how you will do it, how you will make it happen, and which technique is going to scale up. So at this setup, I told you today itself that KNN will take around 1 second for searching top K in 100 million size dataset with this many with one processor having 4 gigahertz as the speed, clock speed. Okay, IVF will take around 100 ms, and HNSW will take less than 1 ms. So which one should you take? Simply that makes sense that you should go with the HNSW, right? Okay, this gives you an answer on scale, latency, everything. Also, if my K value increases, that's what I said, K value increases, then the least effect will come in the HNSW. So tomorrow, if you want to search to a top 20, top 30, the HNSW will be having very, very low latency increment to this 1ms also. The highest being the KNN. So which technique will you again use? Again, HNSW. So what makes sense to scale up your design, make it global payments system fraud detection, whatever it is. It is HNSW that you will take, right? So based on level only, you have to answer the things, right? I think this answers your question.
Yeah.
Okay. Yeah. Yes, please. Any other question? Again, the top K product recommendation, don't answer heap and all those things, right? You answer these things only, vector embeddings, because if you answer those things, then you are gone for sure. I see that many blogs are writing all those things, that we will do sorting, we will manage this heap, that heap. Don't use all those techniques. Yeah, I think so. We are clear with the scope of it. So I wanted to take a master class because I will be busy again and I have to also do enrollment for design and DSA. So all the things at the same time cannot happen. So I hope you have understood the entire workflow, how it is going to work in this session as well. If you have any questions, so the session is comprised of, you can say, 2 months of live coding, 4 months of theory, something like that. And it will be a mix of things. Everything will be coded right from scratch, including the transformers, encoders, everything. And theoretical stuff will be done for 1 month in the beginning. Then you will find practical stuff and the theoretical stuff combined. Any more question that you want to ask?